Hello, my dear future makers. Welcome to ACE Online platform. So, in our ACE Online platform, we are providing the series of ISRO. So, ACE ISRO series it is. So, you know about this marathon from last few days onwards. You are observing and you are noticing the different subjects provided by our eminent faculty. So in today's session also it is a very valuable session to you, and in this session I am going to discuss about discrete mathematics subjects. So in our discrete mathematical structures, if you are preparing for ISRO examination, what the pattern you should follow and what are the important concepts you need to focus, and how to prepare for ISRO, and how they are framing the questions from our discrete structures. In our discrete structures, we have different modules, right? So which module is most important for our ISRO examination? So all these things you are going to learn in this session, my dear. So yeah, let us move on to the session. Yeah, my dear students, myself, Vamshi Krishna, I am the discrete maths faculty of ACE Engineering Academy. So, in our computer science, we have different subjects, and let us see the weightage of the subjects first. After that, I can go to the syllabus, and I can also show the previous year questions from our ISRO examination in our subject discrete math, and later onwards I can also provide some valuable information to you. Yeah, you can take like something called tips and all. Let us see. Students, if you observe our ISRO pattern, in ISRO pattern, if you go to the syllabus, there is no specification for mathematics. Yeah, whereas coming to other subjects, we have some specification. This is the syllabus, this is the syllabus limit. We can say these topics are important and something like this. But whereas coming to discrete math, there is no specified syllabus, but we can take it. But we can take it from our gate pattern. Yes, by using my experience and expertization, I can frame it as syllabus of GATE, because I am just suggesting the GATE syllabus is sufficient. GATE syllabus is sufficient for preparation of ISRO. If you observe the previous year questions of ISRO, you automatically understand that GATE standards are more than enough for preparation of ISRO. Right, my dear? And moreover, GATE is just like a benchmark examination. If you go for any other competitive examination, even state level examination or central level examination in our CSE branch, so the GATE preparation is compulsory. That preparation helps you to become strong in that concepts. So if you see our discrete math, basically we have 4 modules here. Yes, we have propositional logic and first order logic. You can take it as a mathematical logic unit. And next we have second unit, that is set theory, sets, relations, functions, partial orders, lattices, and also algebraic structures like monoids and groups. All these things are available, fine. And next we have graphs. Basically, they can mention the graph syllabus simply connectivity, matching, coloring, but actual scenario is different. In graphs, it is better to us to read all the concepts of graph theory. Particularly coming to ISRO point of view, they are framing the questions from basic level, basic concepts of graph theory, that is important. I did not find any question from matching or coloring. So yeah, if you are strong in basic concepts of graph theory, that is more than enough. And as you are preparing for the GATE, if you cover the complete syllabus of GATE, that is better, right? So ISRO examination is just like somewhat 50% level, and GATE is just like 100% level. So if you aim for 100% level examination, you automatically clear this one. right? And it is possible, and it's not like a new thing. So it is in your hand. You can prepare like that. And next combinatorics topics we have all the principle of countings, and yeah, just like pigeonhole principles and arrangements, permit combinations and recurrence relations, generating functions, dearrangements, all things will comes under combinatorics, my dear. You can take this standard gate syllabus for the preparation of ISRO. Fine. Not only syllabus, my dear, I can show you how the weightage of discrete math. Students, these are the different subjects available in our computer science. So if you take a discrete weightage, the discrete weightage is minimum we are getting 2 questions from this area, and maximum we are getting 6 questions from this area. So on average, you can say we can guarantee like 4 marks. 4 questions you can get in our discrete mathematics. So it is not a less weightage. It is very important, and moreover, it is very affordable. Affordable in the sense you can easily answer the question. It is not at all difficult level question when comparing with our gate, right? Let us see the questions also. If you see the previous year questions, you can understand my words, either it is really true or not. So this is one question we have in the year 2017 ISRO. Yeah, see the question. The number of elements in the par set of 1 2 2 1 1 2 1 1 2, something like this, right? So you know about par set, but if you observe this, the examiner is focusing basically on very fundamental concept. Very fundamental concept in the sense you just see the set here. If you see the set consists the elements like 1 2 2 1 1 2 1 1 2. Let us name this set as A. So what is the basic definition of a set? Do you remember what is set definition? Right? Yeah, set is nothing but it's a collection of well-defined different objects, right? Yes, it's a collection of objects, it's fine. And it's a collection of what type of objects? It should be well-defined, it should be well-known to everyone, and it should be different object. If it is same object, if you repeat the object again and again, I cannot treat it as a different object or different element in the set. I hope you got the point. So in the set, I have, it seems to be like a 3 element set, but actually it's not. Here I have the element like 1 2. This 1 2 is the same as 2 1 1. Yeah, 1 and 1 is same, right? I hope you got it. And here we have 2 1 1 2, something like this. Now if you observe this, these 3 elements are same actually. So if you ask me what is the size of the given set, the cardinality of set A is, I can simply say it is only 1. There is only 1 element is available, right? I hope you remember the basic formula of par set. If there are n elements present in the given set, then the par set consists 2 power n elements. Am I right? So what I am saying is, I am saying in this way, my dear, if card of A is equals to n, then the cardinality of par set of A is equals to 2 power n. In this particular example, we have something like A size is 1, set A size is 1. Now, if card of A is equals to 1 here, then card of par set of A is equals to, it's 2 power 1, that is simply 2. Yes, the number of elements present in the given set is 2, my dear. It's not like 2 power 3, 8, or it's not like that. It's only 2. right? Yeah, I can confirm answer is 2 like this. Students, they are framing this type of questions from our set theory concept. Yeah, I can show the different questions. Now see this. The symmetric difference of a set A is set of 1, 2, 3, 4, 5, 6, 7, 8, and B is set of 1, 3, 5, 6, 7, 8, like this, right? So can you answer this question? I hope you are watching the question. So that symmetric difference of a set A is A and B is so and so. Yeah, symmetric difference is nothing but A delta B. Yes, notation is A delta B, or you can take something like A boolean sum B. That is also okay. Right? What is A delta B formula? A delta B formula is, it's nothing but A union B minus A intersection B. Yes, you can also use one more formula, that is just like A minus B union B minus A. This is also okay. Fine. That is A delta B. My interest is I want to use the first formula. Yeah. A delta B is A union B minus A intersection B here. My dear student, if you observe the sets A and B, if you observe the sets, I think B is a proper subset of A. Am I right? Every element of B is present in A, isn't it? Every element of B is present in A, then I can say something like this. Then A union B is simply A and A intersection B is simply B. Are my words are clear? If B is a proper subset of A, because of this reason, I can say that A union B is A and A intersection B is B. And you know the meaning of difference minus. Minus is nothing but X belongs to A minus B if X belongs to A and X does not belongs to B. Yes, X should be present in the first set and X should not be present in the second set. Yeah, many elements are available. I want element in such a way that it should be available in A, but it should not be available in B. Right? 1, no. 3, no. 5, no. 6, no. 7, no. 8, because they are common. The remaining is only 2, 4. I think answer is 2, 4. That is the symmetric difference. You can call it as A delta B or A boolean sum B. Yeah, the symbol is just like XOR symbol, but in our discrete, the notation is boolean sum. Now we have another question from set theory. This is also ISRO previous year question 2020 like. Yeah, say this. A is a set of XYZ, and B is a set of UVWX, and the universe, every set is a subset of it. All the possible elements are available in that discussion. That is the universe set. You can say it as U or mu. U is available like S, T, U, V, W, X, Y, Z. Now the requirement is A union B bar, intersection, and A intersection B. My dear students, can I expect answer from you? If you are really watching, just give me reply your answer. I can give you 1 minute time. I'm waiting for your response. Yes, to this question, I think B is the correct answer. Yeah, the approach is like this. Here we have what we required. We required A union B bar intersection A intersection B like this. So here A is union with B bar. Let me take all the elements in A. A is X, Y, Z. And B bar means B is U, V, W, X, right? So B bar means from the universal set I am taking the complement set. So that U, V, W, X will not come there. I think I can get something like S, T, S, T, X, not X, Y, Z. I think they are already present, so I don't want to repeat again, right? Intersection. Coming to A intersection B, A here, B here, and intersection, the common elements of both A and B is, I think it's simply X. Now intersection of these two sets, my dear, this is a set and this is a set, the common element is only X. X is the correct answer. Fine. And say this, we have a question from graphs. A given connected graph G is Euler graph if and only if all the vertices of G are what? Yes, the graph is given and it is what type of graph? Connected graph. From every vertex of a graph, if you take any other vertex, there is a path exists. Between every pair of vertex, there is a path, a connected graph. You can reach from any vertex to any other vertex, right? Connected graph. So in this connected graph, a Euler graph, it is a Euler graph. Euler graph means, Euler graph means there is a path, that path can cover all edges, right? Yes, yes. Yeah, the path is here. The path can cover all edges. Am I right? But whereas coming to vertex should be visit exactly once, not more than once. In this job, you are allowed to visit the vertex exactly once, not more than once or not less than once, right? Whereas coming to the path, you can take it as at least once. No, I think it's reverse. Whereas coming to the vertex you can repeat n number of times, no issue. Yes. Every edge you can take exactly once. Edge repetition is not allowed. And whereas coming to vertex you can take at least once. Right? Yes. Now the graph consists something called, the graph consists Euler path. So that's why I'm calling it as a Euler graph. If Euler graph exists, then what do you say about that? If all the vertices of what type of degree? Can we confirm that all are same degree? Or all are even degree? All are odd degree? Or all are different degree? My dear, we have a famous statement that if every vertex in the graph is even degree, definitely there exists a Euler path. Right? If every vertex is of even degree. Yes, I will try to convey with some example like this. My dear, let me take a small example in this way. Yes, I am taking a graph like this. With different vertices and different edges. Yes, my dear, this is first vertex, second vertex, third vertex, fourth vertex and fifth vertex. Yes, it is just like a complete graph, K5. And the degree of every vertex is 4 here, 4 here, here also 4. Degree of every vertex is an even number, isn't it? Degree of every vertex is even number. Definitely there exists a Euler path. Can I show the path like this? But if I draw the path, you may get the doubt. Try to understand properly. The path should cover all edges, all edges. In this coverage, the edge repetition is not allowed. Once if you visit the edge, don't go for overwriting or something, right? But whereas coming to the vertex, you can repeat it, no issue. I think it is better to label the vertex. Let me label it. This is vertex A, this is vertex B, and this is C, and this is D, and this is E. Can I go to the path next? Yes, students, see this. First edge, second edge, third edge, fourth edge, fifth edge, sixth edge, seventh edge, eighth edge, ninth edge, 10th edge. All 10 edges are covered. Like this. Isn't it? My dear, I covered all edges without repetition of any edge. Yeah, some vertices are repeated whenever I am taking the edges like this. I repeated vertex A, I repeated vertex E. Yeah, a vertex can be repeated, no issue. Right? Anyway, what I want to trying to convey is if every vertex is of even degree, definitely there exists a Euler path. Then the graph is known as Euler graph. In similar way, the given connected graph is a Euler graph, which means that degree of every vertex can be even degree. Fine. Now see this question. This is our question from ISRO 2016 year. We have a question like this. The maximum number of edges in n nodes in an undirected graph without self loop. Yes, it is a undirected graph. No self loops are there. They are trying to convey it is just like a simple non-directed graph. Yeah. For example, I want to take n is equals to 4. N is equals to 4. There are 4 nodes. Node A, node B, node C, and node D, like this. There are 4 nodes with me. Now I want to allocate maximum possible number of edges without self loops, without multi edges, something like that. Yeah. My idea is I want to frame a edge like this. This is edge 1. This is edge 2. This is edge 3. Right? And this is edge 4. And this is edge 5. And this is edge 6. Edge 6. My dear, if I have 4 vertices with me, I can prepare the maximum possible number of edges or 6. So, sir, how you are allocating the edge? What the logic you are really following here? My dear, I am allocating edge is just like this. For example, the set of vertices available in the graph is like this. A, B, C, D. A, B, C, D. Like this. Edge is nothing but a connection, right? Edge is nothing but a connection. It is a connection between 2 vertices. So even edge is a connection from A to B. Yes, you can call it as A to B or B to A. It is the edge between A and B because it is a non-directed graph. The right word is it is a join of A and B. That's fine. Now coming to E2. E2 is edge. It is from something called in between B and C. This is the E2 edge. My dear, try to understand. Whenever I am assigning the edge, I required 2 vertices. I required 2 nodes. So the total available nodes are 4. From the 4 nodes, I want to choose AB sometime, AC sometime, or BC sometime, or BD sometime, or AD sometime, or AC, like this. So any 2 nodes from the available 4 nodes. Are my words clear? Any two nodes from the available four nodes. So if you want to assign the edge, we required two nodes to make a connection from all possible four nodes. So it is nothing but 4C2. 4C2 is 4 factorial by 2 factorial into 2 factorial something, right? You can also say something like this, 4 into 3 by 2 factorial 2 into 1. Yes, 6 edges are available and the graph is in front of you. You can observe that. Let us generalize it. If there are n nodes with us, then the maximum possible number of edges is NC2. NC2 is nothing but n into n minus 1 by 2. My dear, this is the most frequent question in our ISRO examination. He touched this area 3 to 4 times. Yes, I can show that. I can show that. Why I am giving the proper explanation to this question. I hope you got it. And some smart student can also understand. Sir, every graph is having a possibility. Sometimes you can take a graph with null edge, no edge, null graph. Sometimes you can prepare a graph with a single edge. Sometimes you can prepare a graph with two edges. So all possible edges are available in front of you just like 4C2. Then how many graphs are possible? So every edge is having two possibility. 2 power 4C2 simple graphs are possible. Yes, 2 power NC2 simple graphs are possible. Okay, now our story is not 2 power NC2. The question is about the maximum possible number of edges. You can simply make it as NC2 and the answer is just like option B, n into n minus 1 by 2. Fine. Now let us take it, my dear. See this question. The question is about spanning trees. The number of spanning trees for a complete graph with 7 vertices, right? So there are 7 nodes with us. How many spanning trees are possible? You know spanning tree, what is meant by spanning tree? So in your tree, the order of tree is the same as order of your graph. And moreover, it is a tree. Yes, it is a tree, n vertices with n minus 1 edges. Yes, n vertices, n minus 1 edges. The graph is acyclic and moreover connected. A connected acyclic graph, which is following adjacency with n minus 1 edges, is known as our tree. And moreover, that tree can be called as a spanning tree if it consists all the nodes, whatever the graph consists, right? V of G is same as V of T. V of G, the set of vertices in the given graph, is same as the set of vertices in the tree also. Okay, anyway, sir, we have n nodes with us. Then how many spanning trees we can prepare? We have the direct formula for spanning tree. The number of spanning trees on n nodes is equals to n power n minus 2. N power n minus 2 in the given question. I think here we have n is equals to 7. Then it is nothing but 7 power 7 minus 2. The required answer is 7 power 5. And luckily option is also available with 7 power 5. Right? So this is one question we got from the area like spanning tree. Now, my dear students, I am expecting answer to this question from you. I don't say anything, you just see the question and give me some reply. Yes, sir, the given graph is a complete graph. Complete graph means everybody is neighbor to every other body. So everybody is neighbor to everyone. Every node is neighbor to every other node, right? So just like K4, K5, K6 you can take. So in all these graphs you can get maximum possible number of edges. That is nothing but NC2. NC2 is n into n minus 1 by 2. Yes, option A is correct. Got it? Now in similar way, try to understand this question. How many different spanning trees are there with 4 nodes A, B, C, D? Yes, the size of the graph, can I take something like this, V of G, the set of vertices in the graph. Chord of V of G, that means a small v, or you can say small n. The size of the graph, not size, order. The order of the graph is 4. There are 4 nodes with me. Then how many spanning trees are possible? The number of spanning trees possible in this case is equals to n power n minus 2. That is 4 power 4 minus 2. Some 4 square it is just like 16. Yeah, 16 is correct answer. Got it, students? And let us see some more examples. And this is the question we have. The number of distinct simple graphs up to 3 nodes. My dear, be careful. The question is not with 3 nodes. It is up to 3 nodes. Up to 3 nodes. Up to 3 nodes means you may think about the number of nodes can be 1, or the number of nodes can be 2, or the number of nodes can be 3. All 3 cases are available, right? Yeah, let me take case 1. If I take case 1 like this, case 1 in the sense the number of nodes is equals to only 1. If there is only 1, the graph available like this, let me take it. That is a graph. Yes, only 1 vertex. Just like isolated vertex. And coming to case 2, n is equals to 2. Yes, we have 2 nodes with us. Yeah, with 2 nodes, one graph is possible like this. This is a null graph. I can name it. This graph name is something called G1, and this graph name is something called G2. And one more graph is here. Yeah, complete graph on 2 vertices like this. So if n is equals to 2, we got some 2 graphs like this. Next, case 3. Sir, we have 3 nodes with us, right? 1, 2, 3. 1, 2, 3. Let me take the nodes like this. Sir, you can prepare a graph without any size. The size is 0. You can take one null graph like this. Can I name it as G4? Right? You can take something called size 1 graph. You can take size 2 graph. Graph should be different, not isomorphic. Graph should be different, right? And you can also take a complete graph like this. Everybody is neighbor to everyone. Yes, my dear, with order of the graph is 1, we have one graph. If order is 2, we have 2 graphs like this. If order is 3, we have 4 graphs like this. So 1 plus 2 plus 4, total 7 graphs we got. Right? The question is not with 3 nodes. It's up to 3 nodes. Up to 3 nodes. First node size is 1 or 2 or 3. All 3 cases we need to discuss. Am I right? Now see this, the maximum possible number of edges, n node, undirected graph without self loop. So ISRO 2008, it is NC2, that is n into n minus 1 by 2. Am I right? Direct question it is. Now see, excuse me, if G is a graph with E edges, E number of edges and n vertices, then the sum of degrees of all vertices is the question, right? So the number of edges available is, the number of edges available is E, and the number of vertices is n, and degree of every vertex. I think we want to find out sum of degrees of all vertices. Okay. Yeah, let us use our fundamental theorem, that is our sum of degrees theorem. According to sum of degrees theorem, we know that according to sum of degrees theorem, we have the sum of degrees of all vertices where I is equals to 1 to n. Yes, degree of first vertex V1, degree of second vertex V2, V1 plus V2 plus V3 and degree of Vn, sum of all degrees of all vertices is equals to the 2 times of edges. Am I right? So the same thing is available here. The sum of degrees of all vertices should be equals to the 2 times of edges, and it is very famous also, it should be even also. The sum of degrees should be even because it is 2e. Na? E can be odd number or even number, it can be always even number. But he did not ask about even number also, he directly asked the question, the sum of degrees of all vertices. So answer is 2e. My dear, this is the reason I said earlier. So if you aim for GATE examination, if you prepare GATE very smoothly, then you can easily clear what do you call the ISRO examination. It is not at all difficult task, right? Now see this. We have another example. Let G be an arbitrary graph with n nodes and k components. Yes, n nodes are available and k components are available. If a vertex is removed from G, then the number of components in the resultant graph, right? The number of components necessarily lies between what are the values. So that is the question. My dear, G is arbitrary graph. It may be a null graph or connected graph or any graph, something like this, right? So n nodes are there and k components are there. So I am removing randomly one vertex from the graph. So if I remove one vertex from the graph, how it is going to be affected? That's the question, right? Yeah, let us make it, my dear. I want to take the first case. The first case is just like this. Let me take a small graph, simple graph. Yes, star graph. A, B, C, D, vertex E, just like this. This is my first graph, something called G1. From this graph, what I want to do is, I just want to remove vertex B from this graph, right? I want to remove vertex B. That means from the graph G1, I am removing vertex B. If I remove like this, then the resultant graph appears like this. D, E, A and C like this. Yes, I already removed the vertex B from this, then the resultant graph is like this. So this is one possibility like. So at this situation, if you observe the number of vertices in the graph, I think it is 5 vertices are there, and the number of components is, it's a single component, it is a connected graph, right? And whereas coming to this, here number of vertices is okay, number of vertices is 4 something, but still the number of components is only 1. Our question is about number of components, right? Let us focus on this. Sir, this is okay. This case is okay, sir. Let us imagine instead of removing vertex B, let us remove something called vertex E, because E is just like a hub vertex. E is a hub vertex. So E is neighbor to everybody. Let us remove that. Let us remove that. My idea is this time I want to remove a vertex called E. So from the graph G1, I am removing a vertex called E. Right? If I remove like this, then I have the nodes like 1, 2, 3, 4. They are A, B, C, and D. Yes, it is a null graph. Yes, it is a null graph. There are 4 components here. Number of components in the graph, k is equals to 4. Yes, it is just like n minus 1. My dear, if you remove just 1 degree vertex from the graph, your graph doesn't affect that much, because the number of components is again 1. But if you remove just like high degree vertex, or you can say in that graph that vertex is the neighbor to everybody, just like vertex E. If you remove such vertex, then the number of components are going to be n minus 1. I think that n minus 1 is the max value. Let us suppose if the given graph is simply something called some graph just G. Yeah, G is an arbitrary graph. Now at the starting of the question they mentioned that it's an arbitrary graph. Second example G2. If I remove this, then the number of components nothing. K can be 0. My dear, the min value is k minus 1 and the max value is n minus 1. So the number of components lies between. For any graph, it may be isolated graph, only one vertex it is having, right? Pendant graph consists only one vertex, right? So what do you say? And a graph, you can call it as a star graph, something called, how can I name this graph? Can I name it as something called K1, 4? Is it okay? Every star graph is a complete bipartite graph, right? K1, n minus 1, right? K1, 4, just like this. From this, if you remove this 1, then the number of components is going to be n minus 1. If you remove some vertex from this 4, it doesn't affect. It's normally k, number of components is k. So let us conclude the answer to this question. So the resultant graph consists the number of components in the range k minus 1 and n minus 1. Option C will be the correct. Got it, my dear? This is one of the good question we got in our ISRO. Right, sometimes the questions are direct like this. See the question. A graph in which all nodes are equal degree. Equal degree, that means degree of every vertex is the same. Yes, degree of every vertex is k. Degree of every vertex is same. Yes, if degree of every vertex is same, then that graph is nothing but a regular graph, right? Yes, it is regular graph. And don't call it as a complete graph. Don't call it as a complete graph. If you have any doubt in this, I will try to clarify like this. A, B, C, D. This is a graph. Yeah, the graph name is C4. It's too regular. It's a regular graph. Degree of every vertex is regular. But see this is not a complete graph. This is not a complete graph, because in complete graph, every node should be neighbor to every other node. A is a neighbor to B, but here A is not neighbor to C. So A is neighbor to C is not allowed. So yeah, it should be like this, right? If it is a complete graph, it should be like this. Yes, every complete graph can be regular, but every regular graph cannot be complete. Anyway, the current discussion is if the degree of every vertex is same, then you can confirm it as a regular graph. Got it, my dear? Now see one more thing. Here we have a simple graph. A simple graph means without parallel edges or self-loop parallel edges, multiple edges are present between same pair of vertices, right? So no parallel edges, no self-loops are there. So in such case, there are n vertices with us and k components with us. Yes, sir. What we required? We required at most how many? At most how many edges? Are n edges available, or n minus k edges available, or n minus k into n minus k plus 1 edges available? So that is the question, my dear. So let us take it. Yeah, let me explain with some example. Yeah, it's a formula actually if you directly put it as a formula, but I can show you the idea behind it, right? For example, my assumption is I want to take n is equals to 8 and I want to prepare some 3 components from this. Is it fine? Yes, I want to prepare like this. Okay, V1 is the first vertex, V2 is the second vertex, and V3 is the third vertex, and V4 is the fourth vertex, V5, V6, V7, and V8, right? Yeah, if you have something called 8 vertices with you, and if you want to make 3 components, the minimum edges is just n minus k. Yeah, just n minus k edges are required. If I take n minus k, sir, what is meant by n minus k? 8 minus 3, 5 edges are, that is enough, 5 edges. First edge, second edge, third edge, fourth edge, fifth edge. That's it. That's it. Isn't it? So now, this is one component. V1, V2, V3, V4, V5, V6 is one connected component. And V7 is one component. V8 is one component. I made 3 component with 5 edges, that is enough. But the requirement is, it is not about minimum edges. It is at most, maximum how many edges. Sir, the same scenario you can think in this way. You just treat all these 6 edges as one thing. Yes, you can take all these 6 vertices. This area is one part. On this one part, how many edges you can allocate, you can make it. Sir, I know this. On 6 vertices, I can prepare 6 C2 edges. I can prepare 6 C2 edges. Am I right? 6 C2. 6 C2 is nothing but 6 into 5 by 2. Some 15 edges. 3 times here, some 15 edges I can prepare. Right, let me see either it is really true or not. Let me check. Okay. Sir, first edge and second edge. If I really require the help of the next vertex, then only I can take second edge, third edge. Right, now let me take the fourth edge. I cannot assign the fourth edge here. I required V4. Fourth edge, right? Fifth, sixth edge, seventh edge, eighth edge, ninth edge, 10th edge, 11th edge, 12th edge, 13th edge, 14th edge, and 15th edge. Am I right? Yes, this is first edge E1, E2, E3, E4, E5, and coming to this E6, E7, E8 and E9, right? And coming to this E10, E11 and E12, 12th edge, and E13, E14 and finally E15. My dear, you can frame at most 15 edges, right? So how do you got this 6C2? This 6 is nothing but 8 minus 3 plus 1, right? This 6 is nothing but 8 minus 3 plus 1, C2. Yes, your idea is 8 vertices are here. You want to make it as 3 components. You just separated 2 components one side and all the remaining 6 components one side. So it is nothing but 8 minus 3 plus 1, total 6. On 6, maximum you can allocate 6 C2 edges. So it is nothing but n minus k plus 1 C2. Right, how do you write n into n minus 1 by 2? 6 C2 is 6 into 5 by 2. In similar way, let me take n minus k plus 1 C2 also. N minus k plus 1, its previous number is simply n minus k by 2. So option D will be the correct one. My dear, this is the logically you can solve the question in this way. But yeah, if you can remember the formula also, it's a frequent formula also. You can remember and you can directly solve the question. That is also okay. Got it? N minus k plus 1 into n minus k by 2. That is the answer. Option D is the answer to this question. Now see this, we have a question from Math Logic also. Identify the correct translation, right? The correct translation into logical notation of the following assertion. Some boys in the class are taller than all girls. Right? There are some boys in the class taller than all girls, and we have a huge discussion about this some boys and all girls and everything. And in our classes also we can discuss some shortcuts like this. Sum is a existential quantifier. It is usually followed by and. Right? And all is a universal quantifier for all. All is usually followed by implication. Right? Now see the scenario. Here, some boys, their exist is followed by and all girls, all is followed by implication. Simply you can put answer is D. There exist some boys in the class. Yeah, there exists some X is a boy. Yeah, it's true. It's not about if X is a boy, X is a boy, fine. And next object, whatever I am taking, if that object is a girl, from the universe I am taking a object, if that object is a girl, then my comparison start. Right? Some boys are taller than all girls. If the second case is a girl, then I can say X is taller than Y. Right? Option D is the appropriate translation to the given question. And we also have something about number of edges like this. The number of edges in a regular graph. Right? Yes, the given graph is a regular graph, my dear. Regular graph means the degree is same, right? The degree of every vertex is same. Degree of every vertex is same. I think the degree is given as D. Let me apply sum of degrees theorem. The sum of degrees of all vertices is equals to the 2 times of edges. Yes, where I carries values from 1 to n like this. Now here, the degree of every vertex is D. So first vertex degree is D, second one is D, next one is D, D plus D plus D plus D n times. D into n is equals to 2 into E. My requirement is about what do you call the number of edges. From this, I can say E is equals to D into N or N into D, D into N by 2. Yes, option D is the correct one. My dear, understand and observe the level of the questions, how they are framing, right? So if you observe the level of the questions like this, then you can easily crack the examination. So this our ACE series will helps you to understand, okay, this is the level of the ISRO question. So if I work out some level, I can really crack it. So that is the main intention of conducting this program. You need to understand. You can compare where you are. You can easily compare the things, right? And see this question. I am expecting answer from you. Can you give the reply to this? Can you say answer to this question? Yes, if you see the proposition is actually it is P implies Q and Q implies P. Yeah, it is nothing but biconditional rule, right? So P implies Q and Q implies P. It is nothing but P by implies Q. Sir, if it is P by implies Q, you know about P by implies Q. If both are true, the result is going to be true. Yeah, it's okay. If both are false, also okay. If one is true, one is false, then the result is false. I hope you are recollecting the truth table. So, in this scenario, you can say it is not always true, it is not always false. Yes, it is neither tautology nor contradiction. It is nothing but contingency. My dear, like this, you can solve the questions from our ISRO examination. And next thing is, this is also from mathematical logic. And the next important thing is, we should understand how our ACE Institute helps you in the preparation of ISRO examination. What ACE offers, let me mention that valuable information also. See this, my dear. We are providing a course called self-paced program. So in this self-paced program, the subject is in very deeper way. So if you want to learn the concepts in very good manner, each and every concept in crystal clear way, it is available in self-paced program and you can purchase it, and 7 days of free trial version is also available. So you can go for ACE online, or these things are also available in Amazon and Flipkart also. So you can purchase from there and you can come to the website and you can purchase there also, right? And we have another course like quick revision course. The idea of the quick revision courses, the every concept in our GATE examination is available here. So every concept with example they can specify, but they don't discuss all the problems. For the concepts, whatever the problem is required, high level problem and basic problems, all the things they can discuss, but the quantity of the problems is decreased, but it doesn't mean that concept is going to be decreased. If you want to complete the course in less time, if you want to revise all the things, then as its name suggests that, so quick revision course helps you, right? And we also offer a course called PYQ. PYQ means previous year questions. So in classroom session or in somewhere, for one concept, some 50 questions are available, let us suppose. So all 50 questions, there are many repetitions. So in that repetitions, if we solve some 20 questions, all 50 questions concepts can be covered. So the faculty may solve all 20 questions, that's okay, fine. But apart from that, the student require a practice. He should be strong in each and every question. It is repeated question, frequent question, whatever it is, he can make a practice. If it is previous year question, at any cost he should not leave the question. So that is not the right way of preparation. So 2000 plus solved questions are available in our PYQs. So, and it's a 200 plus hours of lectures are also pre-recorded videos are available. So you can subscribe to this course also, PYQ. So that is the idea of the course. And all these courses, whatever we are discussing now, these are available in our Hindi language also. So, padhai kare to dil se karo. Fine. And we also have the publication of AS book, that is ISRO examination book. So the cover page of the book is like this. So in this book, 2007 year to 2020 year or previous year questions are available with solutions, and that too concept wise and subject wise, chapter wise, topic wise, everything in a proper order it is available. In particular aspect of ISRO, this book helps you a lot. I think you can go for our website like AS Publications or Amazon or Flipkart, it is available. And these examples can also helps you the preparation of other competitive exams like BARC, DRDO, SAIL, Steel Authority of India Limited, Gas Authority of India Limited, Bharat Heavy Electricals, Bharat Electricals Limited, BEL and CIL and all other PSUs. So my dear students, utilize this opportunity in a proper way. So I hope, wish you all good luck, wish you all very best, and thank you very much. Yeah, see you again. Bye.